In the PureMath exam, there are altogether 20 questions, and paper 1 will have about 10 questions, and paper 2 will have about 10 questions. And after paper 1, paper 2 will be pretty obvious because the same questions are not repeated. So the first question is trigonometry 2D. So we have triangle LMN. So let's draw the triangle. It's a good idea. So LMN and LM is 5, LN is 8.2, and MN is 6.4 centimeter. We have to find the angle LMN. So LMN is this angle, so we can use the cosine rule. So using cosine rule from triangle LMN, so we can use cos of angle LMN equals to, so the included angle, so 5 square plus 6.4 squared minus the opposite side 8.2 squared divided by twice into 5 into 6.4. So we can use the calculator for checking this. So this is 5 squared plus 6.4 squared minus 8.2 squared divided by 2 into 5 into 6.4, and we get minus 0.02. So minus 0.02. So that turns out to be, therefore angle LMN equals to cos inverse of minus 0.02. So that's cos inverse of minus 0.02 is 91.1. 91.1. The answer has to be in 0.1 degree. That means 1 decimal place. That's it. Question number 2 is arithmetic series. This is summation. So summation usually starts from 1, but this starts from 7. So the first thing that we have to do, we have to write down the value of n. So n is going to be the last term minus 7 plus 1. So this is going to be 43 plus 1, 44. So we have to find the sum of 44 terms. So now the sum of nth term, before we find that, we have to find the first term. So summation r equals to 7 to 50. 3r minus 5. The first term is r equals to 7. So 3 7s are 21. 21 minus 5 is going to be 16. Then plus, if you put r equals to 8. 8 3 is 24. 24 minus 5 is going to be 19. So we have this series. So the first term is 16 and the common difference is 3. So that's what we do. So find the sum of, summation is sum of, so this is 44 terms. So S44 is going to be n by 2 twice a plus n minus 1, which is 43. Common difference, 19 minus 16 is 3. So that turns out to be, so 2 into 16 is 32 plus 43 into 3 into 3. That turns out to be 161. So 161 into 44 divided by 2 is 22. And the answer turns out to be 3542. So 3542 is the sum of the terms. The next one is a particle moving. That's kinematics, the motion. So velocity is given, we have to find acceleration. So you have to remember derivative of velocity is acceleration. So acceleration equals to dv by dt. So the derivative is going to be, derivative of 5 is 0, derivative of minus 2t is minus 2, plus derivative of t squared is 2t. So we have to find an expression, and then we have to find the value at t equal to 3. So at t equals to 3, a equals to minus 2 plus 2 into 3. So 6 minus 2 is 4 meter per second squared. So that is question number A. So question number B, we have to find the distance. Now distance is the integration of velocity. It is the opposite. So distance is going to be the integration of velocity. So the limit is from 0 to 4, so it has to be from 0 to 4. So we do 0 to 4, we integrate the velocity, which is 5 minus 2t plus t squared dt. So that would turn out to be integration of 5 is 5t, integration of 2t is 2t squared by 2, integration of t squared is t cubed by 3. So we got the integral. So 0 to 4 is the limit. Now let's simplify. Let's cancel this 2 off for simplicity. So let's put the value. So upper limit goes first. So 5 into 4 minus 4 squared plus 4 cubed divided by 3. So that goes first, minus 0. Since everything is t, everything would be 0. So let's do the calculation quickly. So 5 4s are 20, minus 4 squared is 16, then plus 4 cubed is 64 and divided by 3. So we get 76 by 3. So 76 by 3 is the 76 by 3 is the answer, and the unit has to be in meter. Remember, they have given the unit as meter, so it has to be in meter. So the next question, question number 4. So this is derivative. So we have y as thrice x minus 2 with e to the power twice x. So remember, this is uv. They are multiplied together. That cannot be simplified. So let's differentiate both sides. If I differentiate y becomes dy by dx. Now if I differentiate this is u and this is v. So the rule is u, then derivative of the next one, which is v, plus v, then derivative of the first one, which is u. So you have to write out the first line like this. Then we don't have to do anything to this. Let's find the derivative of e to the power twice x. E to the power anything is the same thing. That's the derivative. And the chain rule is derivative of 2x is 2. Plus the first thing is the same, e to the power 2x. Now the derivative of thrice x is 3, minus the derivative of 2 is 0. So it would only be 3. So let's simplify. So 2 multiplied this. So we can write down the 2 at first. Then we can write this. And we can write e to the power 2x, plus then we can write the 3 here, then e to the power twice x. So they didn't mention anything about simplifying it further, so I'm going to keep it in this way. The next question is question number b. We have to show that this left hand side is equal to the right hand side. So let's do this. So question number b starts with the left hand side, which is thrice x minus 2 times dy by dx. Okay, so let's put the value of dy by dx here, all the way here. So perhaps for this particular sum, it would be helpful if we take this thing common. If we take e to the power 2x common, it would help for the next sum. So this would be 2 thrice x minus 2, plus this would be 3. So this would be e to the power twice x. So 2 3 is 6x minus 4 plus 3. So we will get e to the power twice x. So 6x minus 1. So that would be the simplified version. So we can write thrice x minus 2, and this would be e to the power twice x 6x minus 1. So this is what we got. Now we have to show that this side is equal to 6x minus 1 times y. So 6x minus 1 is already there. So let me write this down here, 6x minus 1. So whatever is left over is e to the power twice x thrice x minus 2. But we already know y equals to e to the power thrice x minus 2 times e to the power 2x. So we can write y here. So thus this is shown. Let's move on to the next one. So question number 5. Question number 5. A water tank is in the shape of a right cylinder, a circular cylinder with no lid. The base of the cylinder is this. Okay, so this is maximum minimum type of sum where we have to show something. So this information is given. This is a cylinder and it is open, and its volume is 50,000 pi. So given the volume is 50,000 pi, and what do we know about this? We know that the height is unknown, but the radius is in terms of r. So we can write volume of a cylinder pi r square h equals to 50,000 pi. We can cancel the 2 pi's and we can write, therefore we can use this. We know this is a common type of sum. The expression that is not here in the surface area, so it is h. So we have to find an expression for h. So that would be 50,000 divided by r squared. Now let's do the sum. Hence the surface area. So the surface area would be given by, since it is an open box, it has no lid, so the surface area would be 1 at the base, which is pi r squared, plus the curved surface area, which is 2 pi r h. So 2 pi rh. Now the expression a has no h here, so we have to get rid of the h. In order to do that, we have to use this expression, this volume 50,000 pi expression. So we can write pi r squared plus 2 pi r h. H is going to be 50,000 divided by r squared. Okay, now this r over here and this r over here, they can cancel off, and we can write pi r squared plus 2 into 50,000 is going to be 100,000, and there's going to be a pi here and there's going to be an r here. So let's check whether this matches or not. Well, it still doesn't match. We have to take a pi common here. So let's take the pi common. So it becomes r squared plus 100,000 divided by r, and we have taken the pi common. Now this expression is shown. So question number B. So question number B, even if you were unable to show this expression, which is 4 marks, you can still do question number B using this answer. So question number B, so maximum minimum at the turning point gradient is 0. So let's start. So first of all, let's find the derivative. So dA in terms of r by dr is going to be, since this is pi, I'm going to use this multiplied version of pi. I'm going to use that version so that it is easier. So pi, so a is pi r squared, so pi is a constant, derivative of r squared is twice r, plus there is an r downstairs. I'm going to write it as to the power minus 1. So if I write this, that would be 100,000 pi is the constant. I'll keep it here. So if I bring the r upstairs, it would be r to the power minus 1. So the derivative of r to the power minus 1 is minus r to the power minus 2. So let me simplify this. 2 pi r, then this is minus, this would be 100,000 pi and divided by r squared. So done. So at the turning point, or at the minimum value, dA by dr equals to 0. We know the rule of the maximum minimum value. So this is going to be 2 pi r minus 100,000 pi divided by r squared. Now the best way to solve equations like that is by bringing everything to the other side. So this is 100,000 pi by r squared, and we can bring the r on one side, r cubed, r squared into r is r cubed, and let's do the division here. 100,000 pi divided by twice pi. The pi and pi cancels, so 100 divided by 2 is going to be 50, and we're going to have 1000. So r cubed is 50,000. Therefore r equals to, so the whole number, the minimum value of a, okay, we have to find the value of r first. So using the calculator, we can write cube root of 50,000. 50, 1, 2, 3, 50,000. Let me do this again. Cube root of bracket 50, bracket close. Some calculators will not be able to understand it. So 36.840. So 36.840. So 36.840, that is the value of r. Now we have to find the value of a. Remember the minimum value of a. So let's calculate this. So when r equals to 36.840, a equals to, so let's put this in the value of the expression of a, that is going to be 100,000 divided by r, which is 36.840, plus r squared, which is going to be 36.840 whole squared, and multiplied by pi. So we are going to use the expression that they told us to show. So if we do this, it is going to be 100,000 divided by 36.840. So that would become this, plus 36.840 squared, we get this, multiplied by shift, so multiplied by pi. So we are going to get 12791. So 12791. So we have a unit here. They told for the value, but even if they ask for the value, it's fine. But if you want to write the unit, that would be centimeters squared. So 12791. Okay, now we have to verify. So to verify, they ask for the question of verify what this is. Verify that the value is indeed minimum. So for that, we have to use the second derivative. So we write second derivative. So the derivative of dA by dr, if we take another derivative, that would be d2a by dr squared, the second derivative. So if we differentiate 2 pi r, so it would just be the constant 2 pi, r would become 1, minus, if we differentiate this, it would be minus 100,000 pi, so this would be minus 100,000 pi, and the derivative of r to the power minus 2, that would be minus 2 r to the power minus 3. So we can simplify this as 2 pi plus this would be 200,000 pi divided by r cubed. So at r equals to 36.840, so the value d2a by dr squared would be 2 pi plus 200,000 pi divided by 36.840 cubed. We don't have to find this calculation. It is obvious from here that it is going to be something positive. So let me just write this down as positive. Then you write down the rule. Since d2a by dr square is greater than 0, it is minimum.